Okay, so what we're looking at today is derivatives of inverses. But before we can do derivatives of inverses, we have got to run over a few things about just inverses. There should be an extra somewhere. I just don't know where it's at, Selena. Okay. I'm going to get those. Yes. Not right now, though. We need to get started on this. Inverses, we need to, this part A of these notes is really just reviewing what we did in pre-cal to make sure we're together on that. Just a few things about inverses we're going to look at. We're going to run through this first part of the notes pretty quickly. F of x and g of x are inverses for every point AB on the graph of f of x, there's a corresponding point BA on the graph of g of x. That's fine. All right, so for this example, we are given a table of values for f of x. If g of x is its inverse, okay, so f of x and g of x are inverses, we want to give a table of values for g of x. So if 2, 5 is on f of x, then 5, 2 is on g of x. Negative 2, 4, negative 4, 6, 0, 9, 1, 10. So when you're looking at a function and its inverse, each point has a corresponding point on the inverse. So if I have the point 2, 5 on my function, then 5, 2 must be on the inverse. If I have 6, negative 4, then negative 4, 6 must be on the inverse. Okay? So you always have these corresponding points. If f of x and g of x are inverses, then the graph of f of x can be reflected over the line y equals x to produce the graph of g of x. Yes. This is sort of like a recap of pre-cal for this part. Because what we're going to be doing is we're going to be taking derivatives of inverse functions. So this first part is sort of like a recap. So any function you have, if you graph it with its inverse, they're going to look like they're reflected over that line y equals x right there. Okay, so if 3, 4 is on the graph of f, name a point that is on the graph of f inverse of x. 4, 3. All right. Okay, so for example 3, it says, given the graph of f of x below, list 4 points that are on the graph of f inverse of x. We're going to do tangents eventually, but we're not doing tangents here. So 4, 0. Okay, so that right here, hold on. Yeah, so this point right here is 0, 4. So over here we would have 4, 0. There's one. Okay, somebody give me another one. Okay, so the point 1, 3 is here. So what point would be on the inverse? 3, 1. Let's see. 3, negative 5. So right here you got negative 5, 3, which becomes 3, negative 5. See. Negative 2, 0. Over here. No, the 3 would be positive. It's the third quadrant, or they're both. On the inverse, yes. In this particular case, I really probably shouldn't use that notation because the inverse is not a function here. The inverse would not be a function. So anyway, we could continue on, right? But it said to give at least 4 points. Whenever you have a point on the original function, you just switch the x and y to get a point on the inverse function. Okay, so this time we know that f of 3 equals 5, f of negative 1 equals 3, f of 5 equals negative 1, and we're supposed to find f inverse of 3. Yeah, we are not finding f of 3. We are finding f inverse of 3. So one way that I've seen, this is a really simple sort of diagram that I've seen teachers use to explain this before. If we've got f of 3 equals 5, that means the function f takes you from 3 to 5. So f inverse is what would take you back. So that would mean f inverse of 5 equals 3. So this one doesn't have anything to do with f inverse of 3. All right. So this one would be negative 1 to 3. So negative 1 to 3, like that. So f inverse would take you backwards. All right. F inverse of 3 would equal negative 1. So negative 1 is the answer here. So, or another way you can think about it is these are the points 3, 5, negative 1, 3, and 5, negative 1. Those are all on the function f. So if we want to know which one would be on the inverse, then we'd have to flip them all. So then you'd have right here 3, negative 1. So f inverse of 3 would be negative 1. More or less, you're looking for the y coordinate here to see what x goes with it. Example 5. Okay, f inverse of 4 would be 0. Right here, f inverse of 4 would equal 0 because this is the point. Because if we're doing inverse, that means 4 was the y coordinate of the original. We're looking for the x that goes with it, so that would be 0. Yeah. Because this is the f of x here, instead of giving you f inverse of x. Okay. Another thing we need to remember how to do is how to find inverses by hand. So to find inverses by hand, we switch the x and y in the original function. We solve for y. We replace the y with f inverse of x. So we probably did not, we talked a little bit about that first stuff that I was showing you in pre-cal. We definitely did this fairly extensively, or as extensively as online school would allow, here to find inverses. So hopefully you didn't photomath your way through this section right here. So that f of x is like our y. And you're going to switch your x and y. So you'll have x equals y minus 3 to the third minus 5. Okay? So Eli, what would I do to solve this equation for y? Good? So I'd have x plus 5 equals y minus 3 cubed. Okay, what would I do next? Yeah, cube root. So we got cube root of x plus 5. Do I need a plus or minus? No. not with odd roots, only with even roots. So if you square root or fourth root or sixth root, you need a plus or minus. But you can take the cube root of a negative number. So you don't need a plus or minus there. And then what's the last thing that I'm going to do? Add the 3. So I probably would write it like that. This f inverse of x equals 3 plus the cube root of x plus 5. Do you guys remember doing this? Okay. Okay. All right. Okay, here's a difficult one. I'm just going to give you a second to see if you can do it on your own. Same thing. Switch your x and y, solve for y. You can switch 2 x's. So it's going to look like this. It's going to be x equals 2y plus 5 over y minus 4. So that'll be the first step, and then you want to solve that back for the y. So see if you can do that. I'll tell you it's a little bit similar to implicit differentiation. The way you solve this is a little bit similar to the way that we did implicit differentiation, which is with the dy dx.
So we use dy?
No, you don't use dy dx.
We do quotient?
No, you're not doing any calculus at all.
Oh,
You're not taking the derivative. It's just a little bit similar to the way that you are going to solve there. Because right now you've got 2 y's and we can't solve for 2 y's at the same time. So you got to figure out a way to get those y's together.
Oh, wait, I remember. Oh, wait, it was something like, I guarantee you, like, you were step up on the board. Oh, I multiply the y somehow.
Yeah, you got to multiply the y minus 4 first.
You just repeat it. Oh, I got it. That's so good. Oh. Something like you split or like there's some kind of rule. I can't remember the rule. Like 3 rules or something.
There's not like a special rule for this one.
Something where like 2, take it up, the top, and
No, you get that. Try multiplying both sides by y.
that's not the stuff you want.
But you can't solve for something else. Okay, so when you multiply by y minus 4 over here, yeah, that's right.
I think I got it. I mean, technically this answer is right. Like you could grab this and it's right. Technically speaking, you would grab it.
Okay, so you multiply both sides by y minus 4. You're going to distribute here. Kind of like the dy dx stuff. We're going to move everything with a y over to one side. And all the stuff that does not have a y over to the right-hand side. Factor out that y. You did not do quotient rule. So we end up with our inverse function is 4x plus 5 over x minus 2. And depending on which side you move stuff to, yours may look slightly different than that. You might have like some negatives in different places, but it should still be equivalent, where like if you multiply top and bottom by negative 1, you get the same. Now this is still not calculus. This is just pre-calculus finding inverses. Okay, questions on that one? Okay, so one other thing that we did is we did the definition of an inverse function. And so we said if f, for functions to be inverse, if we find f of g of x, it has to equal x. And if we do g of f of x, it has to equal x. So I'm just going to do one of these. I think I'm going to skip example 9. But if I want to check to see if these are inverses, okay, to verify that they are inverses, I would have to find f of g of x. And if they're inverses, they should undo each other, right? A really simple example would be like if I've got x plus 2, what's the inverse of x plus 2? X minus 2, right? Those are inverses, adding 2 and subtracting 2. So if I do g and then g, that should be g inverse and not g prime. If I do g and g prime, then I should just get what I started back with, right? Because if I add 2 and then subtract 2, I just have what I started with, right? It's the same idea here, but with a much more complicated function. So if I do f of g of x, I should get x. So f of g of x means I'm taking g of x and plugging it in here. So I'd have 2 times the cube root of x plus 1 over 2 cubed minus 1. The cube root and the cube are going to cancel each other out. So I'm going to have 2 times x plus 1 over 2 minus 1. What cancels next? This 2 is like 2 over 1, so you got one in the numerator and denominator. So that's going to give you x plus 1 minus 1, which of course is just x. So it looks like they're inverses this way. I will tell you that I have never seen a set of inverses where f of g of x works, but g of f of x does not. I do not know if that exists or not, but I do know that they say you got to check both ways. So I'm guessing maybe there's a possibility it exists. I'm not sure. Never seen one, actually. So we would have, this time, the cube root of 2x to the third minus 1 plus 1 over 2. And what's going to cancel first this time? The 1's. So I got the cube root of 2x cubed over 2. What cancels next? 2's. Then I got the cube root of x cubed, which is x. So these are inverses.
So if that were to be on like the proof, we would have to show both of them.
this is not going to be on free response because this is not calculus. But it is something that we need to know in order to do derivatives of inverses, which you're going to see here on part B. Okay? So this is just some background knowledge that we need to have before we move on to part B, which is starting to be calculus. Okay? All right, so let's look at part B now. I'm going to skip number 9 there. It's just doing the same thing again that we just did. And we don't have lots of time, so I'm going to skip it. Okay, so what we're going to be looking for in these notes is we are going to be finding F inverse prime. So like in this particular case, this is the derivative of the inverse of F. So I don't like the notation, but it's pretty much what you got to have. You got F inverse, and then they put brackets around it, and you put this little tick mark outside of it. Mostly just so the -1 and the prime mark don't run together. Because you're doing F inverse prime. Which reminds me that at my training, actually it was after my training, I came across a very good math joke. What is the derivative of Amazon?
What? Oh.
Amazon Prime. Okay, so, alright. Alright, so, okay, so, if we've got f of x equals x to the third here, if I want some points for x to the third power, like if I plugged in -2, what would I get? -8. If I plugged in -1, I'd get 0, 1, 2, 8. Pretty much nothing else is going to fit on this graph, so I'm going to stop there. I'm just plugging these into, I'm just cubing the numbers because my function here is x cubed. Okay, so if I graph those, I've got -2, -8, -1, 1, 0, 0, 1, 1, and 2, 8. So this is my f of x. Okay, so if I want to graph f inverse of x, so I'm going to use green for that. I could find f inverse of x because this is a really easy one to find f inverse of x for, right? So x would equal y cubed. I would cube root both sides, so I'd get the cube root of x is y. So f inverse of x is the cube root. Oh, sorry, the cube inside there. The cube root of x. So, so I could plug numbers into that, or could just switch the x and y columns in my graph, right? I could just do -8, -2, -1, -1, 0, 0, 1, 1. Those don't actually change very much there. So I would have these points, -8, -2, -1. And over here, 2, 8. So this function here would be my f inverse of x. Okay, we are right here. We've just graphed both of these. So, I want to know the derivative of the inverse of f. So, I found f inverse, right? F inverse of x was the cube root of x. I could write that as x to the 1/3 power, right? So, if I want the derivative of this, f inverse, we're going to put brackets around it and put a prime outside. The brackets are just to keep us from losing that prime there. And we'll have 1/3 x to the negative 2/3. Just use the power rule there. And that'll be 1/3 times the cube root of x squared. My inverse. I just took the derivative of the inverse. Yeah. I need to, but not today. We're short on time.
I like it.
All right. Not today though, because we got too much to do. So, all right. So this is our inverse function, right? If we want to know the derivative of the inverse at 8, then we're going to have 1/3 times the cube root of 8 squared, which is going to be 1/. I could figure out what 8 squared is, which is 64, take that cube root, or what's the cube root of 8? 2. So I could just do 3 times the cube root of 8 is 2 squared, right? I can take the cube root first. So I can write it this way, cube root of 8 squared, or I could write it this way, the cube root of 8 squared. So if I think of it this way, cube root of 8 is 2 squared. You can. It's just exponents. So for example, like this, you could write this as 8 squared to the 1/3. And so when you have that, you multiply those exponents together. So it doesn't matter whether you do it this way or if you do it 8 to the 1/3 squared like that. So it doesn't matter the order that they're in there. Yeah. So 2 squared is 4, so you get 1/12. So the slope of our tangent line here at 8 is 1/12, so that would look something like this. Let me draw in that tangent line for us. It would be something about like that. So not a very steep tangent line there. But here's what I want you to notice. This point right here was on my inverse, right? It was the point 8, 2. So what is the corresponding point that goes with it on f of x? 2, 8, right? So 2, 8 is right here. Okay. Let's think about the slope of the tangent line here. So this function f of x was x to the 3rd. What's f prime of x? 3x squared. So f prime of 2 would be 3 times 2 squared, which is 12. Seems to be possibly related to the slope of the inverse, right?